We'll be talking a bit about specifically performance virtualization and that technology here at SolidFire, and really kind of taking that technology and talking about how it enables new storage services within the cloud. I'm Jay Prassel. I'm the VP of Marketing here at SolidFire. With me is Dave Wright, who will also be participating in the phone call this morning along with the slides. A couple of housekeeping items as we get started here. As always, really want to welcome your questions and comments that you may have about the topic that we're presenting today. Take your time and go ahead and place some of those questions into the chat feature, excuse me, into the questions component of the meeting. And what you will do is we've got a series of folks sitting behind the scenes that will help get those answered on the fly. And if we have time towards the end of the presentation today, what we will do is open up the lines to try and do some live Q&A, and we'll have the guys on the phone help us do that. Okay, so just a little past the hour here, so we'll give just a few more seconds and we'll get started. Okay, so again, many thanks for having everybody here, and we're going to hop into it. We've got an hour set up today. We're going to do our best to keep it under that, and obviously give some time for people to get some questions in and get those answered. We want to start, as we start all of our webinars and presentation, and get people all on the same page with what SolidFire is and kind of where we are focused. SolidFire is an all SSD storage system, and we have designed this solution very specifically for cloud service providers. Through the course of the presentation today, hopefully you're going to get a very strong feel for why that is the case, and also come to, I think, good realization that, that the feature set and the items that we have designed into the technology speak very specifically to the cloud service provider set and enable them to do some things uniquely that they could not do before. Quick background on us as a company. We were founded by our founder and CEO, Dave Wright, back in 2009 after his time having spent in Rackspace. He spent about 1.5 years there after selling his previous company, Jungle Disk. And really from his time at at Rackspace is really where the impetus for SolidFire really came from. And obviously we're going to talk about that today, but safe to say there's some very strong expertise both in the cloud service provider space out of Rackspace, as well as distributed storage system expertise here where we borrowed from the Left-Hand Networks team as well as excellent virtualization experience from VMware. So we've brought all these folks together here at SolidFire. We're very well funded today, as you may have seen from some of the press releases we've put out recently, with about $37 million of funding from the folks that you see below. So this is not a goal for us to brag about this, but simply an opportunity to tell you that this company is well put together, well funded, and really on the track towards execution, which leads me to really the final bullet that you see in the bottom of the slide, which is that we have and are in the process of evaluating our product with a very large number of early access customers and have over 500 terabytes of product in their hands today. So we talked a little bit about the market focus for SolidFire. We have a number of those customers kind of across the top of the screen, and these are folks that really we are focused on. This is not a customer list for SolidFire today. This is simply just to give those on the phone a really good feel for the type of customers that we are speaking with and really focused at. And you can see here that these are large public cloud service providers that are in the market today. When you get underneath the covers a little bit of each of these customers, you'll find a series of storage environments that are present there. And we list them out below as local storage, bulk object storage, and what you'll find on the far right as high-performance block storage. And the reason why we lay out this landscape for you is to have everybody on the phone have a really good feel for where SolidFire is focused and also where SolidFire is not. Now, obviously, cloud service providers out there in the world who are doing a lot of virtualization on local machines are leveraging a lot of local storage there, and obviously something that has been in the market for a very long time. In the center part of the screen, you'll see clearly bulk object storage. And for us, I think if you look out at the world and see the kind of what is the knee-jerk reaction to cloud storage, this is clearly bulk object storage, right? You see folks like S3, Atmos, Nirvanix, all playing in this space, and really a space where you put a lot of media files, backup, archival, that type of content. A very important part of the cloud, no question, but it is not the area that SolidFire is very focused in. Our focus has to do very clearly with the far right-hand side of the screen, where you see that we've labeled out that kind of high-performance block storage. And this is the area that we're both extremely passionate about and feel that the full vision of cloud computing really comes to play or brings itself to bear at full force. When we talk to cloud service providers, we ask them, are you happy with just backups and archives and, doing kind of tier 2 applications within the cloud? And I think any application service provider, or excuse me, any cloud service provider would simply say the answer to that would be no. The goal really is, I think, for any cloud service provider to really be able to offer and bring all of the high-performance applications into the cloud that are very key and core to businesses as they operate today. The key to making that happen is the ability to have a very strong primary storage environment that operates within the cloud. And we're going to talk about some of the features of that primary storage and how we feel it should be constructed, and hopefully you guys will agree. So what are some of those applications, and what are some of the options that those applications can live on within a cloud environment? So on the far left, you see some things like MySQL, virtual desktop infrastructure, SAP, Oracle, etc. And when you look out at the cloud, I think you have to ask yourself, well, what are the options? Where could I place these applications, right? I could run them on a dedicated environment, right? That's one option that I have. To me, this is very much what I call kind of SAN relocation. You're just moving the box that you would have purchased and operated in-house and asking someone else to manage it. And in this environment, you clearly get the best performance. It's dedicated, it's your SAN, and you're running on it, right? But obviously, the cost here to customers is extremely high. So there's another level within that, which is managed infrastructure, right? Here we start to see a shared environment start to occur where we have, let's say, multiple customers within a single environment, yet it is heavily managed. It requires a lot of right sizing and a lot of work from the cloud service provider to make sure that these systems are sized appropriately so that customers don't step on one another. And as much application visibility as a cloud service provider can get, the better it is for them, okay? But at the end of the day, it's very difficult to guarantee performance in this environment, okay? Because even though I do the best to manage it, I'm unable to silo and firewall performance between customers. If you look at the third option, where you could put, something like virtual desktop, SAP, or Oracle, it's the cloud or a fully shared infrastructure. Most people probably hearing that kind of wince, right? Who would put SAP in a full cloud shared environment, especially in a public cloud? Very few would do it today. And one of the biggest issues behind that is simply the inability to guarantee performance. Cloud, one of its main components is very high tenancy, and if there are a large number of tenants of which a cloud service provider cannot visualize and manage the applications that they're using there, there's a huge issue, right? The ability for one customer to capitalize and step on the performance of another is there. Yet, in the cloud environment, the cost structure for a cloud service provider is at its best, right? This is where margins are great and where you have obviously a very high number of customers in a single or maybe one or two infrastructure environments. So really the question comes down to, how do you now combine or really provide to your customers as a cloud service provider in the space the ability to have dedicated style performance at the cost of cloud infrastructure? And that's part of what we want to discuss today, as well as discuss some of the options that you can now layer on as a business around this capability. So as a final piece, oops, what you see here within this environment is that if you're an infrastructure as a service provider, or maybe you are a customer looking at an infrastructure as a service provider, you today can get SLAs that exist around availability and uptime and are very focused on that. Yet there is truly no availability of a performance SLA that exists or operates right around storage performance. Now there you get some prioritization. Those options are certainly there today. But as a hard SLA, those simply do not exist. And we feel very strongly that if you have the ability as a cloud service provider to offer a guaranteed level of service around performance, you now open up new business opportunities and new business models which you can then take advantage of. And you also now have the ability to invite these applications that you see on the left-hand side of your screen into your cloud environment with a much higher level of confidence than you ever could before, and at a much better profitability than you did before. Okay? So it begs the question then, what should primary cloud storage look like in really a perfect world? And what I'm going to do is actually we're going to shift gears a little bit and have our CEO and founder Dave Wright kind of jump in and start to kind of pick up the ball here a little bit and chat a little bit about this. So I'm going to turn it over to him for a moment.
Hi, this is Dave. So as Jay was saying, I think the options that are available for service providers today to offer block storage services are limiting. You can either have dedicated services that are, can provide good performance but are extremely expensive and probably overkill for most people, and then you can go all the way down to kind of cloud-based block storage services on commodity hardware that provide very good economics but very little in the way of performance guarantees and challenges with performance and reliability. If you look at the ideal cloud storage offering, if you look at what an ideal block storage offering would look like from a customer's perspective, that is a customer that's going and looking to purchase cloud services and looking to put high-performance applications in the cloud, I think there's a couple of key aspects that are just missing in the offerings that service providers are able to provide today. And certainly one of those is multiple tiers of performance. In your compute environments today, there's typically many, many different offerings for level of performances. How many virtual CPUs you want, how much RAM you want. You can get a pretty wide range of performance. But with storage, it tends to be all about capacity, and you really don't have any sense of what performance level you'll get, and you don't get any guarantees around performance. And so an ideal storage environment would be one in which a customer can choose not just the amount of storage capacity that they're buying, but the exact amount of performance that they want as well, and have a scalable range of performance from a few hundred IOPS for a very modest application to thousands or tens of thousands of IOPS for very high performance applications, but be able to move up and down within that performance level to wherever their application requires. The second thing that you would really look for is not just having different levels of performance, but really some SLAs and some guarantees around performance. The ability to have customers set expectations for customers and allow them to see consistent levels of performance on a day in and day out basis. Give them that feeling of a dedicated environment where the performance they get on day one is the same performance they get on day 100. And I think that is, that is something that is extremely difficult to do in any kind of multi-tenant storage system today. And when it comes to multi-tenancy, you want a storage system that is very highly multi-tenant, one where you can have thousands of customers in a single storage environment, and not something where you have to partition it down to 1, 2, 3, 4, or 5 customers in a storage environment, because not only is that very expensive, it's very cumbersome to manage, and it loses a lot of flexibility and a lot of the kind of great thing about cloud, the ability to kind of burst up and down and have a large pool of capacity that everybody can tap into. And the last thing is that, of course, you want it to be cost effective. While it's great to have all the performance and all these capabilities, if it's going to be cost prohibitive, if it's going to be something where the customer says, you know what, I can just do that cheaper with dedicated hardware or cheaper in my own data center, then it's not going to be a compelling offering. And so you really want to be able to offer these dedicated quality of service levels at pricing that's competitive with shared storage. So when you really look at what it takes to offer performance storage, performance block storage at cloud scale, we really think it comes down to 3 key elements. And the first is this performance virtualization piece, the capability to address the question of how do you guarantee storage performance to thousands of volumes in a cloud environment at the same time. The second is inline efficiency. So in order to make it cost effective, how do you have a storage system that can be all solid state and can be profitable in the cloud? And these are some of the questions we're going to answer in the presentation today. And we think the last key piece is system automation. If this is going to be a true cloud scale storage environment, how do you automate every aspect of that storage system, from provisioning, management, billing, error handling, everything that a customer needs to, everything that the operator needs to manage with the system? How can you automate that so that your environment can continue to scale? So these are the questions that we think are really key to looking at performance storage at cloud scale, and we want to talk about how we address these items with the SolidFire system. So if you take a high-level view of the solid state, of the SolidFire solution architecture, there's a couple of really key aspects to it. First, and certainly what many people know us for, is that it's an all-solid-state solution. It is not based on spinning disk, but based on flash-based solid-state technology. No spinning disks whatsoever. The second aspect to it is that it's a clustered scale-out storage system, which means that rather than something where you have many islands of storage, when you need more storage capacity, when you need more storage performance, you can simply add these 1U building block nodes to your cluster, get more capacity, more performance, and the SolidFire system will manage the distribution of data, the distribution of volumes, the distribution of load, in order to keep things balanced both from a performance perspective as well as a reliability perspective. The third thing is that we built this architecture, we built this system on industry standard hardware. This is not something where we've gone and reinvented the wheel. The move to having storage systems be based on industry standard hardware, Intel processors, industry standard interconnects, that's clearly the way the storage world is going, and we've certainly embraced that with our architecture. The real magic to what we do is in the software layers and in the optimization that we've put on top of this hardware to manage large amounts of flash storage very efficiently. The interconnect for the system is 10 gigabit Ethernet, both for the cluster interconnect as well as the storage network, and right now all of our storage networking is done over industry standard iSCSI. I think the thing that people are really most surprised about when we sit down and look at the SolidFire system is that when we built this system, we built it very differently than other solid-state systems that are out there. There are certainly a number of other solid-state storage systems that are designed for performance first, and cost is really a secondary consideration, because really they're designed to address the 1 or 2% of applications where performance at any cost it can really be justified. But with the SolidFire solution, we really have designed this for large-scale cloud-type environments, places where obviously performance and capacity and reliability are critical, but cost is critical as well. You have to be able to have a profitable storage offering, and so we've designed this system to use efficiency technologies that allow you to get to a usable dollar per gigabyte number that is very similar, if not actually better than what you can achieve with the disk-based SAN today. And at the end of the day, this clustering technology that we have allows you to combine up to 100 nodes in a single cluster, which is over a petabyte of capacity and over 5 million IOPS of performance. Take a breath. Are there any questions before we continue? Please go ahead and type them in, and we'll try to address those as we go. So the first really key aspect of our architecture that I want to talk about is the performance virtualization capability. And really what this can be thought of is the capability of taking a storage system and separating your performance from your capacity. Rather than the traditional storage architecture, if you've got a big pool of storage, you can carve it up into different capacities, but the performance you get is really all dictated by the actual media that's running on, or how many drives it spanned across, or how much capacity you've devoted to it. We found a way in our architecture to completely separate performance for capacity and allow you to dial those in separately for every single volume in the system. And essentially what that means is you can have small volumes with a very high level of performance, or you can have large volumes with a relatively modest amount of performance. In our storage system, you're neither wasting performance or capacity in those scenarios. If you've got a small volume with a lot of performance, the capacity that that's not using is available to other volumes. If you've got large volumes with a small amount of performance, the performance they're not using is utilized by other volumes in the system. They really are completely independent pools. And what it means as a cloud provider is that you don't have to have a one-size-fits-all offering. You can have offerings that span wide ranges of performance and wide ranges of capacity and allow those things to be dialed in independently. The second thing is, when we think about performance, we think about guaranteeing performance and guaranteeing quality of service at a volume level to every single volume in the service and doing it based on real metrics. And we'll walk through exactly what that looks like in the field. But this is very important because when you talk about quality of service with storage, most storage systems really don't have anything. The few storage systems that have quality of service, it's all based on relative prioritization. It's not based on hard numbers like IOPS and bandwidth, which is key to having a viable product offering. The other thing is that we actually have the ability to do volume level throttling of performance, and that's extremely important for a service provider who wants to offer multiple tiers and multiple levels of performance. If you sell a customer the lowest performance tier, but because the system is lightly loaded, they're able to get ridiculous levels of performance. Number one, they have no incentive to upgrade, and number two, as that system fills up and less performance is available to them, they're actually going to be dissatisfied with the service, even though they were getting a great deal early on. So by setting a specific level of performance, guaranteeing that performance, but also limiting that performance within a certain window, you end up with a much more consistent, predictable product offering for customers. The last piece of it that we think is really key is the ability to adjust performance and adjust the quality of service levels in real time through our REST-based API without actually physically having to migrate data. In our storage architecture, in order to speed up or slow down a volume, we don't actually have to move any data blocks around. So this is not a tiering architecture where we're having to move data to faster or slower media. It is a true virtualization architecture where, just like CPU virtualization, you can turn the knob up and down as to how many cycles an individual virtual machine gets. With our performance virtualization technology, you can turn the knob on exactly how many IOPS each volume in the system gets. So what does this look like in practice, and what kind of controls do we give to the service provider, and ultimately, if the service provider exposes it to them, to the customer in the cloud environment? So first of all, when we think about quality of service, again, we're thinking about it in real terms like IOPS and bandwidth, and we allow you to control quality of service for both of those in our system. In this example, we're just going to look at IOPS. The really important thing with our architecture is that we don't have the IOPS setting for a volume being a single number. There's a number of different reasons for that, but in particular, we've designed this system to work very well with real-world workloads where more simplistic quality of service schemes or more simplistic throttling schemes would give you significant performance problems. So the way the system works is each volume in the system actually has 3 configured levels of performance: a minimum level, a maximum level, and a burst level. And the way that the system works, if we look at the maximum IOPS, the maximum IOPS is essentially what the target level of performance that the storage system is going to try to deliver to that volume. So day in, day out, if the application is requesting that much performance, that is the target that we are going to attempt to deliver to that application. And 99% of the time, that's probably the performance level you'll see. Now, there is a separate min-IOPS configured value as well. And where min-IOPS comes into play has to do with what happens if the storage system becomes overloaded. We've got a tremendous amount of performance in this system, about 50,000 IOPS per node, scaling up to about 5 million IOPS in a single cluster. So there's a lot of performance there, but there's certainly always the possibility that customers, that the system gets over-provisioned. A lot of customers get on there, and that there's a lot of contention for resources, or failures occur that reduce the available pool of performance. So there's certainly always the possibility of running into performance bottlenecks. And with most storage systems, when you hit that performance wall, it really is like hitting a wall. Latency shoot through the roof, storage performance for everybody gets absolutely horrible, and really there's very little that you can do to recover from that. In our system, we've taken a much more kind of prescriptive approach to it, which is every volume in the system has a separate minimum configured level of performance. And the storage system, if it detects that it's getting near performance limits, it will actually scale back the performance that's being delivered for customers from their max IOPS towards those min IOPS. And it will do it in a way that is proportional to the difference between those numbers. So you can have customers that are very high priority customers or high priority applications that are maybe paying a premium where the delta between their minimum and maximum is not that large, and they're not going to get scaled back very much in an overloaded situation. And you can also have customers where there's a very large delta, and those customers maybe are lower priority, and they will be scaled back very quickly if performance becomes limited. And this is all something that we're hoping will be very seldom used in practice because we have such a tremendous amount of performance available. But it's important to know that it's there, and it's important to know from the perspective of communicating expectations to customers that if performance limits are reached, performance will degrade in a very predictable, consistent fashion, and it doesn't become the wild, wild west. The last limit in here is one that I'll discuss by example, and that is the burst IOPS limit. And the burst IOPS limit comes into play because we know that most storage applications do not run at a consistent level of traffic, do not run at a perfectly consistent number of IOPS. A lot of benchmarks may do that, but real-world applications don't. Real-world applications are bursty. You have things like database checkpoints, table scans, web page hits, things that cause a short-term burst of I/O, after which it returns to more normal levels. And so what we've designed into the system is this capability to burst above the configured maximum for a volume for short periods of time. And the way that works, I'll illustrate here with this illustration. The blue line represents the level of performance, the level of IOPS that are being requested essentially or delivered to an application. In this case, initially it's requesting or being delivered 100 IOPS, which is configured right at its maximum, but then it has a lull in activity and that level drops. Again, not because we're limiting it or we're throttling it, just because the application isn't requesting as many IOPS. And you'll see these maroon bars start building up. And what these maroon bars represent is credits. Essentially, for the time that a volume is running below its configured maximum, we will allow it to build up credits, and these credits can then be consumed by the application when bursts of activity happen. So when a burst of traffic happens, the volume can now go above its maximum IOPS up to this burst IOPS limit, which can be set at really any level you want, and it will run at that burst IOPS limit until it consumes those credits and then is capped back at its maximum again. But what this control gives you in the real-world scenario is the ability to have applications that are very bursty and yet are not abusing storage resources, are not continuing to consume large amounts of storage resources, but also are not being artificially capped just because they had a short burst of activity. And it's really the perfect quality of service mechanism to ensure a balance of both fair storage utilization as well as great end-user application performance. And for the service provider, having these controls and having 3 separate controls here means that you've got a wide range of product offerings you can build off of this. You can build product offerings that are high levels of performance but low levels of guarantees. You can build products that are lower levels of performance but very consistent and very high reliability. And you can also build products that allow a wide range of bursting capability as well. And we don't expect customers to have hundreds of different products or expose every nuance of this quality of service system to their customers, but it does give service providers a lot of flexibility to define product offerings that are both differentiated in the marketplace and even differentiated among other service providers who may have similar quality of service capabilities. The second big focus for architecture is inline storage efficiency, and this is really all about how do you increase the amount of effective capacity that you get out of a storage system. How do you increase the amount that you can sell versus the amount that you purchase? And with SolidFire, this really comes through 2 things. The first is that compared to a traditional disk-based storage system, you're able to run it at much higher levels of utilization. A lot of our customers with disk-based systems only run at 20, 25%, maybe 30% utilization, because beyond that they tend to have significant performance problems, and also because for scaling reasons it's harder for them to add capacity, add performance And so they tend to buy all of their capacity up front and run at relatively low levels of utilization over the lifetime of the storage system. With our system, both because of the balance of capacity and performance we have, as well as the quality of service controls, and also the scale-out nature of the storage system, it's much easier to run the system at higher levels of utilization than what you would traditionally do with a disk-based environment. But beyond that, we have built into the architecture inline real-time data reduction technologies like deduplication, compression, and thin provisioning as something that is not simply an add-on or something where you can trade kind of performance for capacity, as with most storage systems, but something where this is an intrinsic part of the architecture and can be run across the entire data storage system without performance impact. And the combination of these two things, this high level of utilization as well as these data reduction technologies, drives a drastic reduction in power, floor space, and cooling. And if you compare utilization of storage in a SolidFire system versus a traditional system, you'll see there's a huge difference. Namely, with a SolidFire system, you'll find that you actually end up with more usable capacity, more sellable capacity than what you're purchasing, versus a traditional storage system where you purchase extremely large amounts of capacity, but at the end of the day, there tends to be only a small portion of that that ends up being able to be sold out to customers. Now, we certainly hear a lot of concerns, a lot of claims about the efficiency numbers and the efficiency claims and how much savings can you really get out of it. And so to help customers really understand what these efficiency technologies, what these data reduction technologies can do in their environment, we've created a tool called the Efficiency Scanner, or the E-Scanner. This is a very easy-to-use command line tool that we distribute, and you can actually sign up on our website and receive a copy of it. And this tool is used to scan data in your existing environment, look at the type of representative data, the type of representative volumes that you might put on SolidFire, and actually get actual measurements for the amount of savings you will get from thin provisioning, compression, and deduplication based on your actual data, and not based on the estimates that we might put out. So you can see the URL to it. You can find it on the SolidFire site. And certainly if you have any questions about it, we're happy to address those. Just feel free to put them into the chat. The third area of focus for us is the management piece. And this is the piece that I think is most overlooked by traditional storage vendors who are selling enterprise storage systems into cloud service providers. And the reason is that they're bringing all the enterprise management tools with them, and management tools that are really focused on storage administration rather than storage automation. Or when they have automation, it's really automation to help a storage administrator, not automation to help run a business. And really that is what these storage systems represent to a cloud service provider, is the fundamental building blocks of their business. And control over those building blocks is absolutely critical. And so automation and automated management is really at the core of everything we do with SolidFire. And part of that is a REST-based API that is completely comprehensive, covers every single aspect of the SolidFire system. Everything that can be managed with SolidFire is available in this API. And really our own management tools are just built on top of this API. So there's no secret sauce. There's nothing you can do in our management tools that you can't do yourself through these APIs. So everything from initial cluster stand-up, adding of capacity, multi-tenant provisioning, security, reporting, billing, all of those capabilities are in the API. And it's really been designed around what a service provider needs to scale and manage their storage environment. And this API is available. We can share it with you if you're interested. It's a very easy to use REST-based API. It can work with any programming language. And if you built your own cloud management framework, if you built your own data center automation framework, it's very easy to plug into that. If you're using a commercially available or an open source cloud management framework, we're actually doing a lot of the work up front to do those integrations, to make it so that once SolidFire has been integrated with these cloud frameworks, you don't need to worry about direct storage management at all. It's all managed as part of the cloud framework as customers come online, set up their virtual machines, provision new volumes, attach them to virtual machines. All of those things can be handled automatically for you. So those are the three big tenets and the three big areas that SolidFire focus on, trying to address those problems that we'll come back to in a second. But I do want to just give a little bit closer look at what is the hardware, what is the system that is behind kind of all these capabilities. if you look at the actual systems that we're selling or getting ready to sell, the building block for them is a 1U storage appliance. They've got 10 2.5-inch SSDs in it, about 12 terabytes of effective capacity per 1U, and about 50,000 IOPS of performance. As I mentioned, the connectivity is all Ethernet based. It's iSCSI over 10 gigabit Ethernet, and the system is scalable from anywhere from 5 nodes to 100 nodes in a single cluster, and that would give you over 100,000 customer volumes, 5 million IOPS, and a petabyte of effective capacity. And that's not to say that you're going to necessarily run your entire cloud operations off of a single SolidFire cluster. There's many different kind of configuration options for how you would deploy it. There's many different kind of types of clusters or cluster sizes you might choose to deploy, and we can certainly discuss those with you. But it's just important to keep in mind that we have a wide range of flexibility. This is not a storage system that is going to be outgrown in most cloud environments. Yeah. So I'm going to hand it back over to Jay now, and he's going to really talk about what this means to you and wrap up the presentation today.
Awesome. Thanks, Dave. And hopefully everybody else on the phone has been finding this interesting and following along. If you've been doing email or checking out some other things, I want to kind of pull your attention back to us here on the webinar, and as we kind of wrap things up, because what we want to do is take a lot of the technology that Dave has been talking about around performance virtualization, inline efficiencies, and automated management, and really bridge them to what we feel is a great business opportunity for cloud service providers in a variety of different areas. And one of those main areas really focuses very heavily on the ability to bring high-performance primary storage applications into the cloud with a very high level of confidence, right? We talked earlier about how storage that gives us the best performance in the cloud today is dedicated environments, and how costly those things are. Yet a full cloud infrastructure has one of the best cost components to it, but it's impossible to guarantee application performance because a service provider has no visibility to the applications running within the environment. And how do we combine those two things together? And we do it within the SolidFire solution through those 3 elements we talked about. So if you look back on the screen here and we reconnect with these high-performance primary applications, what can you now do with SolidFire's performance solution? Obviously, there's the ability to offer multiple performance tiers that we can also now track and bill against in a very intelligent way. You have the ability to stand up very hard SLAs around storage and assign those SLAs to each and every one of those tiers. That becomes a very powerful business opportunity, I think, for everybody on the phone to be able to be much more predictive and much more accurate with the services that they provide. A lot of people talk to us about, auto-tiering solutions and things of that nature. And, the goal isn't to open that debate here, but the thing I want to place in people's mind is the idea of, instead of having storage systems that react to application need, why not move the question forward and ask your customer, how much performance would you like for the SAP volume that you're going to place within my infrastructure? Wouldn't that be a better way to solve this problem than having to have some automated thing trying to figure it out on the back end? Let's ask the question up front and then empower our customer to change that volume's performance on the fly on a regular basis, right? And we can now track and bill for it in an intelligent way. We've talked about the ability to change performance on the fly, and I think when you put a wrapper around all of this, you kind of step back from performance, efficiency, and management and ask what is the thing that I as a cloud service provider can do. I can really set and maintain a customer's expectation within my system over time, okay? Because obviously those applications on the left-hand side of your screen are key. They're key to business execution, right? They're not just a backup. They're not an archive file. This is what operates businesses day to day. And the guaranteed performance and the predictability of performance is very important to them. So I think you raise the interest level of your customer, you differentiate yourself as a provider, and you maintain that expectation over time. The final bullet here simply talks about the massive savings and the efficiencies that you gain when you're running inline deduplication, compression, and thin provisioning, and how that has a huge impact also on your bottom line from not only the amount of storage that you have to purchase, but also the amount that you power and cool, and again, use over time. Okay? So hopefully that is clear to everybody. If it's not, again, feel free to throw some questions in on the chat. So this brings us now back to kind of where we started, kind of the three main pillars of SolidFire's environment around performance virtualization, inline efficiencies, and automation. And we look at the questions that surround these, the primary one being, how do you guarantee performance to thousands of customers within a shared infrastructure? You could ask this a different way and say, how do I have 1,000 SAP environments executed and operating with confidence within a shared infrastructure? That's a question most people don't ask, but we're really encouraging the cloud service providers that we're working with, and those of you on the phone, to ask this question, both of yourselves and other vendors that you may be speaking with. It's an important thing, I think, to get your head wrapped around. Obviously, we feel that SolidFire enables you to do that, and that has been kind of the core of our conversation today. We support the ability to have this, we support performance virtualization with inline efficiencies that help us drive the cost down. Dave talked earlier about how we were able to deliver this system at or below traditional performance disk cost, and we do that obviously through the inline efficiencies that we have within the platform. Because again, as a cloud service provider, as you offer a business to your customer base, you may have inline efficiencies, but if you can't manage the performance intelligently, do you have an accurate solution? It's our thesis that the answer to that is no, right? Or what if you have inline efficiencies, but you can't automate the system? Does that make sense to you? Or maybe you can't automate it and you can't virtualize performance. I mean, all these, I think, are very good questions, and the reason we place the three of them on the screen together is they have to be talked about in concert, okay? I think that is where the power of the SolidFire solution is, and it also is where the power for your solution to your customers resides as well. The ability to manage performance intelligently, make it cost-effective for you from a business perspective with inline efficiencies, and automate that system in the very same way that you automate your compute nodes. So at the end of the day, when we kind of wrap it all together, you know, SolidFire is really enabling you to guarantee a quality of service to thousands of applications within a shared infrastructure. And we want to run you through an example. This is an example that we use a tool that we've developed internally. Then when we sit down with cloud service providers, we walk them through what you see on the left-hand side of your screen. We start off with what is the effective amount of storage capacity that you would want to begin with. Customers of ours do not have to go ahead and start with hundreds of terabytes because this is a scale-out storage system. It allows them to grow as they require it. In this case, we used 50 terabytes, and we talked about a 3-year amortization schedule. And what we do then, through the use of the eScanner, is we go ahead and take the 85% system utilization and then the information that they give us, right? All of you on the phone can do this. You can go ahead and grab eScanner, understand what your world looks like from an efficiency standpoint, and we're going to take that and use that in this calculating tool here. In this case, we use a multiplier of 2 for compression, deduplication, and thin provisioning. Okay? And then we get into, again, some of the more of your business around what would you choose to charge this storage service out at? What's the average customer size that you expect? And what's the growth? How often do you feel customers will come into your environment? Now, these are all things that you can flex and change, but I think it's a very powerful tool to help you then understand a couple key things that we have highlighted in the box to the right, okay? Where you see time and customers that are required to recover on my investment. What kind of margin dollars do I see over the 3-year period? And what are the nodes that I purchase as my system and my customer base continue to grow? Okay? And what we're able to show for all of our customers that we speak with is a very clear executable business model. We spent a lot of time talking about technology today, which is important, right? We want to be able to back up the claims that we make around efficiency and around performance virtualization. And Dave has helped us really, I think, get our heads wrapped around that well. But it's my effort really here to help you understand that there's a clear business focus of SolidFire, and our ability to deliver this information to you, I think, is very strong. So if we've kind of struck a chord with you in our conversation today, I want to urge you to have you pick up the phone, head out to our website. We've got an option where you can hit talk to us and we'll reach back out to you, where we can both talk about the opportunities that you have and where you're focused, but we can also then spend time really getting into the details of your business and make sure that a SolidFire solution is a net add to your business, not just a big cost because you're trying to solve a performance problem, right? We feel you can solve the performance problem and have an effective business model right in concert with it. So if you have any questions, my contact information is there on the screen. You certainly can hit our website as well. Lots of great information out there. There's a great video on performance virtualization. You'll find it right at the home page. So if you maybe you got caught up in emails, we were chatting today, feel free to head out to the web and check that out.